In this tutorial, I'm going to show you how to make starter content water materials work on any size static mesh surface. Let me show you what this means. So if you go inside starter content, inside materials folder, there are two materials, lake and ocean. And right now, if I apply any of these two materials onto a small enough static mesh, this will work just fine. Let me enable real time. But if I take this static mesh and let's say I want a larger water plane, so I'm going to scale this 300 by 300 and apply the same material onto it, the water material will be stretched out and distorted. And it doesn't matter if I use lake or ocean, the material is unusable. And it should automatically tile regardless of the size of the static mesh, but it doesn't. So the way we're going to fix this is by creating a material instance and then defining some properties within the material itself, so then we can change those parameters and make the water tile across any size static mesh. So to get started, I'm going to go to File, New Level, and use a default new level. The default level has four important actors that makes the water work. We have a directional light, a skylight, reflection capture, and a skybox. For the static mesh, we're going to use starter content shape plane. So we're going to go jump back inside starter content folder, shapes folder. We have shape plane. I'm going to drag this into the map, and this is what we're going to apply our water onto. A simple plane is the best way to have water inside your level. So you just have a simple plane that's one-sided, and then you apply your water material on top. So I'm going to move this down, and I'm going to scale this 1000 across X and Y. Another important thing you want to do for your water plane is to disable collision. So I'm going to scroll down until I come to collision, and collision presets set to no collision. I also want to insert a human reference scale into the map. This will help us to judge scale of the water when we begin to adjust properties within the material instance. For this, I will use Mannequin Mobile, which is free. You can download this and add it to your project. I'm going to go inside mesh folder and drag the mannequin into the map. And this will help us to judge scale and proportion of the water when we have our material instance. And last thing I'm going to do is I'm going to save this map inside my maps folder. And I'm going to name this water test. Alright, now we are ready to begin working with our water material. Let's navigate back into starter content, materials folder, and we're going to work with water ocean material. If you want later on, you could repeat the same steps for lake. I'm going to duplicate this water ocean and pressing Ctrl W. You can also right click and choose duplicate. I'm going to keep this default name, M Water Ocean 1. The reason we are duplicating this material is because if anything happens, I can always revert back to original material and start over. So with the duplicated material, this is the one we're going to make all the changes to. Now I want to select the duplicated material and create a material instance out of it. Right click and choose create material instance. I'm going to keep this default name. Let's go ahead, double click on the material instance. By default, we have three parameters available to us: water base color, water crest color, and noise speed. These are obviously not enough to do anything with them. We will be adding our own parameters and adjusting everything so we can use this water material. So let's go ahead and close this, and we'll come back to this later. I'm going to take this water instance material and apply it to our water plane. And now we want to go ahead and double click on the water material, the duplicated water. And this is where we're going to be making all the changes, and the changes and the parameters we add will drive and show up inside the material instance. Let's go ahead, come back, and I'm going to disable real time. So we can break this material down to 3 areas. And these are the areas that we're going to focus on. Large waves, which appear in the distance. Small waves, which will appear close by next to the player. And the transition, the gradient between the small waves and when they begin to transition to the distant, larger waves. First, we're going to set up parameters to control large waves. And this will be done in this section of the material, right here. So let's go ahead and zoom in. And the first thing we want to do is add large wave tiling, which will be controlled through this texture coordinate. We will need to add the parameter so we can change it inside the material instance. And in order to change and add a parameter to a texture coordinate, we need to have a multiply and a parameter that will control a value. So I'm going to add multiply by holding down M and left clicking, and a scalar parameter. Hold down S on the keyboard and left click. This is the same node as if you were to create a constant 1 vector and then simply right click and convert to parameter. This is the exact same thing. So in order to bypass convert into parameter, just insert a scalar parameter. So as you can see, this texture coordinate already has U tiling and V tiling. We are going to control both of these through the same node. That means we're going to control U and V through one value. But if you want to break up your texture coordinate and control U and V tiling individually, to do this you would need to have an append node. So you would do this. You would create 2 scalar parameters. One would be to tile along U, the other one would be to tile along V. You would connect them to append, and then you would connect them like this. So then inside the material instance, you would be able to control U and V. But in that case, I just need one. I'm going to control through a single value. So I'm going to delete these, and I'm going to plug the scalar parameter into B, texture coordinate into A, and then multiply into the panel coordinate. And now I want to name this scalar parameter so we can better understand and see it inside the material instance. And this is going to be named large wave tiling. And the default value I'm going to set this is 1. Next, I'm going to set large wave speed, and it's controlled through this panel right now. So we need a parameter to control it inside the material instance. And when you select the panel, you can see that speed X and speed Y has certain values set. So we need to control these, and we're going to add a scalar parameter again. Hold down S on the keyboard and left click. I'm going to connect this into speed. I'm going to rename it to large wave speed. And set the default value to -0.03. Again, if you want to control the speed X and Y individually, then you would use the append, and you would have 2 different parameters for X and Y speed. But I'm going to use a single value to control the speed instead of 2. I'm trying to keep things simple, but you can always break them up into individual parameters. Next, we're going to go into this section right here, sign control pan and normal texture. And we have a parameter that's already been created for us, and it's called noise speed. This controls the back and forth water movement speed. So we're going to keep this, but I want to rename this and give it a better name. And the name we will give is large wave noise speed. And we will keep the default value of 0.4. So now we have large wave tiling, which will control the tiling of large waves. Then we have control for large wave speed, how fast the large waves will move. And then we have large wave noise speed, which controls the back and forth movement of the water. Next two parameters we're going to add are large wave movement tiling and large wave world position tiling. So the first one is this texture coordinate right now is set to U and V tiling at 0.18 and 0.15. We're going to control this, and this will be our large wave movement tiling. So I'm going to add a multiply and a scalar parameter. Again, you can break this down into U and V tiling individually using the append and two scalar parameters. I'm keeping this simple and using just a single value. So I'm going to rename this scalar parameter to large wave movement tiling. Gonna set the default value to 1. And I'm gonna hook it into B. Take this texture coordinate, plug it into A, and multiply will go into coordinate of the panner. Again, we are working inside this sign controlled pan and normal texture section, which we're working and controlling our large waves tiling and speed. And then the last parameter for our large waves is going to be this absolute world position divide mask. This is very important, and this controls the repetition of large waves, and it will help to break the noticeable pattern of the larger waves in the distance so they tile better, so you don't actually notice the tiling. So for this, all we need to do is select this constant 1 vector, right click, and convert to parameter. Default value is going to be capped at 150, which is what was set inside the material, and we're going to rename this, and I will rename mine to large wave world position tiling. So now we have our 5 parameters to control large waves: large wave tiling, speed, world position tiling, noise speed, and movement tiling. Let's go ahead, hit apply, and take a look. All of these will now show up right here inside our material instance. Next section we're going to focus on is small waves tiling and speed, and this is controlled through this section inside the material right here. So we need a parameter to control small waves tiling and to control the speed. This is very similar to what we did for large waves. So for tiling, I'm going to insert a multiply node and a scalar parameter. This is going to control the tiling of small waves. Gonna take this texture coordinate, plug it into multiply A, this scalar parameter into B, and multiply into panner coordinate. Gonna select this scalar parameter and rename it. I'm gonna give the name of small wave tiling, and set the default value to 1. And second, we're going to control the speed of our small waves. So for this, all I need is a scalar parameter, and it's going to be plugged into speed of the panner, and I'm going to rename this parameter to small wave speed. And I'm going to set the default value to the panner's -0.07. So now we'll go ahead and hit apply, and these 2 parameters will now show up inside our material instance. The last part is controlling the transition between small waves, which are going to be close up to the player, and large waves, the distant, far away waves. And there's a transition, a gradient that you can control of where this transition will happen. And this is done through this section inside the material, creates gradient far away from the camera. There are 2 values that set that control, but we only need one, and it's this one right here at 2000. Now, in order to have this inside our material instance, all we need to do is convert it to a parameter. The default value is going to be set at 2000, and we're going to rename this to wave transition small to large. Let's go ahead, hit apply, and save. And this wave transition small to large will now appear inside the material instance. There are a few additional parameters that you could add, but when I tested this, it didn't add any significant changes to the material. So I did not add them. You can go ahead and test, see if you get any changes, but I ran the tests and I chose to leave them out. These are large scale tiling, modulate pixel depth with noise, and there's a panel here inside the sign control panel normal texture. And it's this one right here for control and speed. And these three, again, they don't add any significant changes to the water material, so I left them out. And everything we need, we already added, and these 8 parameters is what's going to control our water material, and it will make it tile across any large surface static mesh. So now we are done with adding parameters into the material, so we can go ahead and close this. And we are now ready to begin enabling and controlling how this water material will tile across our water plane. Let's go ahead and pull this off so we can begin changing our values and see the water. So I'm going to move this off to the side, expand this down, and make sure you enable real time so you can see the water movement as you change and update your material instance values. So the first properties we're going to focus on are large waves, which are going to be far away from the player. So you want to get nice and high so you can see the distant horizon and the further away large waves. And the values that you're going to be using will depend on how large your water plane is. So if you remember, we scaled our plane 1000 times. So these values may not exactly match your plane unless you are following this tutorial exactly. Also, I ran and did the tests, so I know ahead of time which values I'm going to be using, but you'll have to kind of play around with your water plane and see what looks good. So the first 3 values I'm going to control are large wave tiling, large wave speed, and large wave noise speed. Large wave tiling, you go ahead, begin to change and see how it affects your water. Now, the values that I chose that looks good for this water is at 300. Large wave speed is going to be lowered to negative 0.01. And for large wave noise speed, I'm going to keep it at 0.4. The next 2 are large wave world position tiling and large wave movement tiling. For large wave movement tiling, begin to increase this, and the values that I chose for this is 400. Now it's beginning to look a little bit better, and the distant waves beginning to tile more appropriately. And the large wave world position tiling, this helps to break up the offset so you don't see this repetition. And the value for this I'm going to use is 800. Looks a lot better now. So if we get down and take a look, all large distant waves look pretty good. The next 2 are small wave speed and small wave tiling. And for this we need to get up close to the player. These are the waves that are going to be happening right here next to the player. So we have distant waves, which are large waves, and we have small close-up waves. So right now this is still distant to large waves. So for small wave tiling, I'm going to change this to 400. That's already looking better. And then we want to change speed, and negative 0.07. I like how this looks, but again you can change it to depending how fast you want. I'm gonna reset it to default. And last is wave transition small to large. This is the distance where small waves begin to transition to large waves. So let's go ahead and enable this, and if I go ahead and lower this, you can begin to see this line. This is the transition between small and large waves. And for this, default is pretty good. I'm going to increase it to a little larger to 2500. Now it might be very difficult to see right now, and you get this weird gradient on each side of the screen, and you don't get a full sense of how this water looks. Something's off. So this is due to the default skylight, which is right now, let me move this off, is set to static. So you want to have a skylight in your scene, but you want to make sure that it's set to stationary. And this will fix the dark gradient artifacts. So now we can go ahead and kind of fly up, and we have much better looking water in the distance for large waves and close up small waves. And again, you want to play around with these values in the material instance and get them to look exactly how you want your water to look based on water plane scale that you have. Make sure you save your material instance. And for the last part is you want to blend the water plane to the sky a lot better. And for this we want to use exponential height fog. We have atmospheric fog ready in the scene that comes with the default template, but it doesn't use fog as best as exponential height fog will. So we're going to leave this in because it does define and work with our sky sphere, but we want to go ahead and insert exponential height fog. So go to visual effects and drag exponential height fog into the scene. It's already beginning to look a lot better, and we have our horizon blend with the sky and the water more accurately. So I'm going to select the exponential height fog, I drag this up, and I want to define a few properties. I want to change fog density to 0.05, set fog height falloff to 0.4, and start distance to 500. And again, you want to change these values based on your scene. So this is what I thought looked good for this scene, but these will vary. So play around with these values. So now we have our water material instance from starter content, and we have the ability to make a tile across any static mesh water plane surface, no matter how large or how small we make it.